Hey everyone, you're watching a demo video for Hydra App SDK and Auction Service Catalyst project, a collaborative effort between MLabs and Ikigai, and today we'll be going through the Hydra SDKs that should facilitate rapid development of Hydra-based applications in PureScript. As part of the fifth milestone, we have extracted some reusable components from the Hydra Auction Off-chain project and created a new GitHub repository named PureScript Hydra SDK. This initial SDK draft offers various typed interfaces and functionalities designed to be useful for any Hydra-based applications. One important note here, we use types defined in the PureScript Cardano types repository, meaning that the Hydra PureScript SDK should be naturally compatible with CTL, which is Cardano Transaction Library, a framework for building Cardano transactions of any complexity. That said, we don't enforce the use of this particular off-chain framework, and using a solution other than CTL is perfectly fine, but it may just require some additional integration work. So let me switch to my IDE and walk you through the different parts of the newly published Hydra SDK. So as a developer of a Hydra-based application, the first thing I probably want to do is I want to spin up a Hydra node with the right configuration. And that's basically the purpose of this module here, which is re-exported from Hydra SDK process. So I suggest we just go through different definitions in this module because the module itself is quite compact and very important at the same time. The main function here is spawn Hydra node, which, as you may guess, launches a Hydra node subprocess, and it accepts a list of startup parameters defined here. So for example, we have configuration for our Hydra head peers, and so on. So basically, just various startup options. Then we have a list of Hydra node handlers, the interesting and the most important one being API server started handler, because it gets executed on API server startup. So it's basically the point in time when we want to initialize a WebSocket connection to the Hydra node API and start communicating over this connection. Next, let's move on to what I consider to be the most important part of this SDK, which is an interface for communicating with Hydra node or WebSockets and HTTP. And I suggest we just cover HTTP first because we only have one request here, which is used to submit funds from L1 to L2. And it accepts Hydra commit request, which can either be a simple request with some UTXOs or a full commit request with a blueprint transaction. And the purpose of this blueprint transaction is to provide some transaction context. So for instance, if we have some UTXOs logged as a script address and they have some checks for, let's say, transaction volatility range, we want to specify this range correctly in this blueprint transaction so that this transaction can later be complemented on the Hydra node side and successfully submitted. So that's the idea behind this commit request. And I guess we can just move on to the WebSockets. So here we have make Hydra node API WebSocket function that accepts this builder, and the interesting fields here are handlers and transaction retry strategies. So let's just cover handlers first. We have message handler, so we basically want to handle incoming Hydra node messages somehow. So these incoming messages can either be successfully parsed into Hydra node API incoming message, or on parsing failure, they will be returned in a row, so they can be handled in some other way by the client application. Okay, so let's just go through some of those messages. For instance, we have greetings, which is emitted on Hydra node startup and contains some important information like current head status defined here. So for instance, all those Hydra domain specific types are being re-exported from Hydra SDK types, and it also contains some auxiliary types we use like host port and network and so on. So next we have head is initializing, which is quite important because we want to be notified once we can actually commit some funds to L2, and that's probably the place we would like to do so in most cases. Then we have a committed message, which we receive once we observe a commit transaction from one of the peers. Head is open when all the parties have committed and we observe a successful collect commit transaction as mentioned here in this comment. And yeah, we also have this UTXO here, so this is the initial UTXO state. And so on. So as you can see, we handle those messages in a type-safe way. Now let's cover transaction retry strategies. So it is known that contest and close transaction can actually be silently dropped by Cardano node, and we need to have some mechanism to retry those transactions. And we basically provide this mechanism here. So for each of those transactions, it's possible to specify this Hydra transaction retry strategy here. So what we do is we can either specify that we don't want to retry transaction at all for some reason, or we want to retry submitting this transaction if the specified success predicate has not been met after the specified delay. And the delay should be selected carefully because it will be different for different network conditions. So if you know that normally a transaction takes about 2 minutes to be confirmed by the network, it is reasonable to specify like 120 seconds for this delay. And for closed transaction, we also provide this default close head success predicate, which basically checks the status of the head. So once we know that the head has been closed, it is not necessary to retry this closed transaction for obvious reasons. So the last part I would like to cover here is the return type of the main Hydra node API WebSocket, which is basically a record of actions that can be performed against the Hydra node. And as you can see here, we have initialize head action, abort head, close head, challenge snapshot, fan out, and of course submit transaction L2, which accepts this transaction type as mentioned before. We have many types in this SDK that come from PureScript Cardano types repository, and therefore it is advisable to use CTL with this SDK as an off-chain framework, although it's not strictly required. And this record is also passed to the message handler so that you can execute some actions as a response to some incoming messages from the Hydra node. So that should be quite convenient for users as well. To conclude, we have covered some of the crucial components of the PureScript Hydra SDK. We are currently in the process of upgrading Hydra auction off-chain to use this new library, and as part of the next milestone, we plan to provide a minimal working example utilizing our SDK. Those integration efforts should help us identify any weaknesses or shortcomings in the current approach, which we will address before releasing the first version of the Hydra SDK. So thank you for watching and have a good day.